Okay, today we're going to look at 8.2 compound interest, and we're just going to look at it in its future value. We'll rearrange things later. Right now, let's just get an understanding of what compound interest even is. Okay, so recall from simple interest, interest is the capital I. It's the money earned on an investment or the additional money owed on a loan. Principal is P. It's the original amount of money. The amount is the total amount, and that's our capital A, so it's our starting amount plus our interest. R, our little r, is our interest rate, and remember we have to write that as a decimal. Our term T is the length of time that the money is vested and borrowed, and remember we have to keep that in years, so sometimes you have to make a conversion. We've got a few new words today. So our new words is compound interest. So that's being calculated using the principal and its previously accumulated interest. Interesting. Compounding period is how often the interest is added to the principal before the next interest is calculated. Interesting. So what does that even mean? So let's look at our explanation here. When money is borrowed or invested, the interest is added onto the principal after a certain period of time. So not at the end, during. And then once it's been added on, the interest is going to be calculated again. So now it's being calculated on a larger amount of money, the principal plus whatever interest you've already gotten. Okay, so that new amount is going to be bigger. This procedure continues for the entire term of the loan or investment. This is why credit cards get so big so fast and people can't pay them off. Okay, because credit cards are compound interest. Let's take a look at this. Okay, so what I've done here is I've just created a quick little simple spreadsheet. This way I can type in any number I want for my starting amount, and I can change my interest rate to whatever I want. So let's see, if I were to have $1,000 at 5% interest rate after 1 year, I would get 50 bucks. So my new amount is going to be $1,050. Okay, so simple interest, that's just how it works. My principal never changes. It's always 1,000. My interest is still being calculated based on that. My new amount is, we just add those two things together. But over time, like if I did that every year, then my new amount would be equal to, the years before plus my new interest. Okay, assuming that principal never gets changed. Right, so I would get it up. And then if I were to graph this over time, we just get a nice little graph. Let's make that. Okay, so here I've just graphed it. I've got time on the bottom. I've got the amount on the side, and we're just dealing with 5% right here, right? So simple interest over time is just linear. Well, what does compound interest look like? So compound interest, the first year would look like the same. However, what happens is that my principal now becomes my new amount. So when I go to calculate my interest on my new amount, well, now I'm paying more. So now I'm getting bigger. So if I keep that going all the way along, if I keep increasing and increasing how much my principal is, well, look at this. It's now making a bigger amount. So let's put that into our graph. Okay, so I just popped that into a graph. I just changed my stuff into dollars. So what we see is that over time I'm getting more and more interest, and my line is no longer linear. It's now becoming exponential. So let's see what happens if we do it even more time. All right, so let's see what happens. So here's my simple interest table. So if I go for, say, another 15 years, so my linear trend continues. Now if I bring up my compound, so here's my compounding one. So again, I want to bring this up to about 15 years. So if I keep my same pattern going, look what happens. Now we really see it start to take off. And this is the power of compounding interest, is this exponential curve. Because look at this. My new amount, I end up with $2,000 versus simple interest, which was only, what's that, 1,752. That's a big difference. Okay, so we saw the two comparisons, so I just popped that into our notes. Let's look at what happens. Like, that was just compounding once a year. What happens if we compound other ways? So there's more ways to think about this. So we got to talk about our equation. We got to talk about a few things here to fully get this whole big picture that we're trying to put together. So our equation in this for compound interest looks like final amount is my principal times 1 plus I to the exponent n. So A is still our final amount. Sometimes it's called the future value. P is still our principal, so our initial amount, our present value. We need to deal with the fact that this is now an exponential, so it's 1 plus how my interest rate is changing, and we're going to be altering that a little bit because we have to divide by how often it compounds in a year. And n is going to be my total number of compounds, so the number of years times how often it happens in a year. So R is the interest rate as a decimal. N is the number times interest is paid each year, so that's my compounding period. So my I is going to be equal to R over N. Okay, time is included in this exponent here, so my exponent is my time times my number of compounds in a year. So what are the different words we're going to look at? If we see annual, my N will be 1 because I'm being paid once a year. If it's semi-annual, it'll become 2 because we're paying interest twice a year. If it's quarterly, then my N is 4 because I'm paying it 4 times a year. Monthly, so we've already talked about that we have 12 months in a year. So I'm getting paid 12 times a year. Bi-weekly means every other week. So remember, we have 52 weeks in a year. If I'm being paid every other week, then that's 26 times in a year. So my N is 26. Weekly is the number of weeks there are in a year. So 52. And daily is 365 because we have 365 days in a year. Okay, so now that we know these numbers, we're going to be seeing one of each of these words in every single one of our questions. So we got to pay attention and we got to know what they are. We're going to do these little conversions off to the side every time. So we've got a little bit more work to do with our compound formulas. Okay, let's just try some converting, interpreting kind of things. So we want to determine the values of P, N, and I from our formula. A equals P bracket 1 plus I to the N. All right, so Mary's going to invest $500 for 5 years at 8%. And now here comes these keywords, compounded semi-annually. So that compounded semi-annually is extremely important. That's my big N value. So that's how often it's happening every year. So my big N is 2 because semi-annual is twice a year. So our principal is our starting amount. So we're going to start with $500. Our little I is our interest rate as a decimal divided by my number of compounds per year. So my interest rate is this 8%. Okay, but we have to turn that into a decimal, so divide by 100. So this is going to be equal to 0.08 divided by 2 because my semi-annually is 2. So my inside my brackets, my I is going to be equal to 0.04. My little n, which is my exponent, is my time in years times the number of compounds per year. So I'm being told 5 years times semi-annual, which is 2. So my exponent in that equation is going to be 10. So when I go to pop everything into my equation, I would have my principal, 500, 1 plus 0.04 inside the brackets to the exponent 10. Okay, let's look at this one. So Raymond's going to borrow $300 for 3 years at 5% compounded quarterly. So remember, quarterly happens 4 times a year. Let's go back to the start. We're going to borrow 300, so that's my principal. My I is my interest rate as a decimal divided by how often it happens in a year. So 5% is the same thing as 0.05, right? Divide by 100. So you get 0.05 divided by quarterly, which is 4 times a year. My little n is my number of years times my number of compounds per year. So I'm doing 3 years quarterly. So that means I'm going to be compounding interest 12 times because I'm doing it 4 times for every 3 years. So in this case, my equation is going to look like A equals 300 bracket 1 plus 0.05 divided by 4, or you could calculate that, that's fine, all to the exponent 12. All right, let's do an example where we actually calculate what things are going to be worth. So we've got Renata. She's going to invest $500. So that's an important number, $500 at 5% compounded monthly. Monthly is 12 for 4 years. So there's my time, there's my interest rate, there's my principal. What will the investment be worth? So that means I need to find my final amount at the end of the 4-year term. So there's this time I just repeated myself. We're dealing with compound interest, so A, P, I, N. Okay, my final amount is what I'm looking for. My starting amount is 500. Okay, our I, remember, is our interest rate as a decimal divided by my number of compounds in a year. Yeah, that's in my way. So my interest rate as a decimal, so 5% becomes 0.05. And this is happening monthly, so it's over 12. So we're going to be putting in the answer of, okay, so that's a big long decimal. So let's stick with the first bit. So 0.0041, that would round to 7. And then our little n is equal to our time in years times my number of compounds per year. So in this case, I've got 4 years, and I'm compounding monthly. So that means my little n is going to be equal to 48. Okay, so let's put all this into our equation. So our equation, remember, is A equals P bracket 1 plus I, all to the exponent n. My principal, which is my starting amount, is my 500. 1 plus this big long decimal, all to the exponent 48. So when we go to calculator this, watch your order of operations. I would just add my plus 1. And then I would calculate that to my exponent. So I've got plus 1, all to the exponent 48. So you should get 1.22 as what your brackets equal. So we've got 500 times 1.22. So that gives us an answer of $610 and round it 45 cents. Therefore, the investment is worth $610.45 after 4 years. All right, let's look at example 3. So we have an investment broker who's talking with Tony. Tony has $2,500 available to invest. We're going to invest at 6% per annum, and we're going to look at 2 different investments. One is going to compound monthly, one is going to compound bi-weekly, and they're both going to last for 3 years. So we need to figure out who's going to make more money, which one's going to give us more money. So let's figure this out. My bi-weekly scenario, so we're looking for our final amount. We start with 2,500. We are talking about doing this for 3 years, and we're talking about an interest rate of 6%, which convert to your decimals 0.06. So that's going to be the same for both of them. The only difference that's going to happen is in my I, which is my R over N, and my little n, which is my time times n. So when we're doing bi-weekly, that means it's going to happen 26 times in a year. So my I becomes 0.06 divided by 26, and my little n becomes 3 times 26, and 3 times 26 is 78. So let's pop all that into my equation. A equals P bracket 1 plus I to the exponent n. So we have 2,500 bracket 1 plus my I is 0.06 divided by 26, because biweekly happens 26 times a year. N is 78. So let's put that into our calculator. So I'm going to type in 0.06 divided by 26 equals plus 1 equals. So I'm going to have 2500 bracket 1.0023 all to the exponent 78. I'm not even clearing my calculator. I'm just going to say my answer to the exponent 78. And then I'm going to times that by 2500. And my final answer is going to give me $2,992.42. So now let's calculate what's going to happen with monthly. So monthly, pretty much everything's going to still be the same. So my monthly equation, we've got my big N is now going to be 12 because it happens 12 times a year. I'm still looking for final amount. My starting principal is still going to be 2,500. My time is still 3 years. My interest rate is still 6%, so 0.06. So in this case, my I is going to be my R over N, which is 0.06 divided by 12, because it's happening 12 times a year. And my little n, so my exponent, is going to be T times N, so 3 times 12, so that's going to be equal to 36. So let's finish this one off. So we need to calculate. We have our equation A equals P bracket 1 plus I to the little n. So I'm still starting with $2,500. 1 plus little I, which is 0.06 divided by 12 now. All to the exponent 36. All right, so I'm going to calculate what's inside my brackets first. So I end up with 2,500 times 1.005 all to the exponent 26. So that's going to equal exponent 26. 1.138 is going to be that value. So I have 2,500 times 1.138 times that by 2,500, and you are looking at a grand total of monthly $2,846.15. So you can definitely see in this case, monthly did not make you as much as bi-weekly. So when you compounded more, we can see that you make more money. So that's pretty exciting. So more money is made when you compound more frequently. So therefore, the more frequent we compounded, the faster the money will grow. So there we go.